humanities and the sciences came up in the last session, whether the humanities are in the same position as the sciences in terms of their public face. I was actually thinking in the conversation about how much kind of democratic oversight there should be for research in the humanities. And in a sense, what we need is a philosophy of failure akin to the philosophy that Professor Firestein has articulated for the sciences. We need to convince the public that actually failures in the humanities in our research can be productive of new knowledge too. So we'll hear from him about that in a moment. So I want to introduce our panelists, all of whom have really interesting and varied experience working between history, sciences, and public outreach. So Stuart Firestein is the chair of Columbia's...
Former chair.
Congratulations.
Thank you. Very important word to go with chair.
Okay, so good news of biological sciences here at Columbia. He studies the vertebrate olfactory system, meaning the question, how do we smell? And he has been very dedicated to promoting access to the sciences, most recently by my own field of history science and philosophy science. And he's been reaching very wide audiences through a variety of media. He published in 2012 a fascinating book called Ignorance, How It Drives Science, and then most recently a book called Failure, Why Science is So Successful. And our next speaker is going to be Merlin Chowkwanyun. Now we're very lucky to have him in the history of public health at Columbia. He's an arrival, and he works on the history of health policy, racial inequality, and social movements. In a variety of different projects, book writing, but also activism. One of the books that he's writing now questions the dominant theoretical assumptions and frames in racial disparities research, so it's a real practical application. Joel Fry is the curator for Bartram's Garden, the home of John and William Bartram in Philadelphia. And he's been studying these gardeners and botanists for many years as an archaeologist, a historian, an anthropologist, and he now runs this really unique museum in Philadelphia. Finally, Erika Goldman is the publisher and editorial director of Bellevue Literary Press, which is a nonprofit, mission-driven publisher, publishing literary fiction and narrative nonfiction at the intersection of the arts and sciences. And books that she's published have won a remarkable number of literary prizes, and she'll show you some of the books and tell you more about those. So I won't list all the prizes, but it's very impressive. So we'll start with Professor Firestein.
Okay. Yes, you can put something up there if you want. All right, I'm just going to make a couple of very brief remarks because I'll have an on-board discussion, I hope. So in the August 1st, 1964 issue of a popular magazine then known as the Saturday Review, there was a short article by the noted immunologist Peter Medawar, also a Nobel laureate scientific spokesperson. Medawar was recognized for his work in immunology, seminal work in immunology, in which he sometimes he's called the father of organ transplant, although he generally rejects that title. His seminal research was into the manner in which our immune system recognizes self from non-self. And while his work was very fundamental, it was sometimes called basic research, no particularly intended clinical application. It did, of course, explain the basis of organ rejection and so paved the way for the development of more imagining immunosuppressive drugs and things like that. Medawar, this is a picture, there's also well known, at least in Britain, as kind of the Carl Sagan of biology. So he had very witty, affable explanations of difficult scientific concepts for public audiences. The article in question here is the one up there. He published this paper called "Is the Scientific Paper Fraudulent?" Is the scientific paper fraudulent? And his answer, as you can see, is yes, absolutely. And so he goes on to explain the article. It does not mean that the scientific papers misrepresent facts or that the interpretations in them are wrong or deliberately mistaken. What he does mean is that, as phrase here, I guess, basically that the scientific paper misrepresents the process of scientific thought. So scientific papers, which many of you are probably familiar with, but just to quickly kind of review the idea, are the main vehicle really by which scientists communicate their work. They don't publish books in general, so it's all done by papers. And they follow a fairly rigid format. They're presented in 4 sections, maybe, they're presented in 4 sections. Each has its particular purpose and a tone to it. So there's the introduction that reviews the current state of the field, provides a context and rationale for the experiments to follow. The next is the method section, which simply describes the means utilized to carry out the experiments that are going to be presented. The results section is a little tricky. It details the findings from each of the several experiments, but it's a supposedly dispassionate presentation of the findings or the data with no interpretation or specific value attached to them. Finally, there's the discussion, which presents a very clever theory, which will tie the results together into a comprehensive, hopefully comprehensible explanation of whatever it was you introduced as the problem way back in the introduction. The ridiculous conceit of all this, and the one that Medawar took issue with here, was that this marvelous theory that appeared in the discussion seemed to appear rather miraculously as a result of the dispassionate experiments you so fortunately chose to perform back in the results section. So of course it's a total fraud. So first of all, of course, the discussion should probably come first, because no one really starts a set of experiments without some idea of how they want them to work out. Often they don't work out that way, but in the discussion you don't state that. You just change the discussion around to reflect the actual results. I have had many a conversation with the graduates in the lab and said to them, look, let's get some data first and then we'll come up with a hypothesis. Because that's really, in many ways, the way that the process works. So further, it's of course rare that the experiments detailed in the results section actually occurred in the order that they were presented. That, in fact, would look like total chaos. The results are now, in fact, however, lined up in a tidy narrative progression that takes you from one result to the next experiment in perfectly logical and linear steps, but it never really happens that way. Experiments are half-baked experiments, sometimes are done and then revised, returned to later after new data comes in, performed only because data from a new experiment shows that you really need an earlier experiment to make sense of that one, and so forth and so on. And so the real process is actually a mess, and the paper is a very cleaned up version of that messy process. So I always tell students in my lab that when you read a paper and a paragraph begins, as it often does, with the phrase, "we reason that," you should immediately write bullshit in the column next to it, because that's often always the case, in fact. So now, in fact, this is actually a perfectly reasonable way, I think, to present findings from a scientific investigation. And there'd really be no sense in having readers go through the messy, often years-long process of discovery and development of the results, the experiments that worked, didn't work, why they didn't work for this reason or that reason, not to mention the extended discussion of what they mean or might mean that inevitably took place among the experimental team. So while some parts of that process might be enlightening to a few scientific readers, in general it would be incredibly inefficient. And none of us would want to get mired in all that. Nonetheless, a fraud is certainly being perpetrated, and that fraud, it seems to me, is the distortion in the public's mind about how science happens, about the so-called scientific method and other methodologies about science. It leads to a view of science that's very mechanistic, as though it's some sort of engine of facts, devoid of creativity, inspiration, idiosyncrasy, mystery, and most importantly, and I will discuss high rates of failure. There's uncertainty, there's doubt, there's risk. It actually requires courage and, of course, a great deal of patience. You have to listen to nature when she screams at you, and failures are nature screaming at you, so you have to have a fairly high tolerance for that. The other damaging mythologies that seep into science education and the general perception of science in the culture to me are these sort of what I would call the heroic narrative, the supposed Eureka moment shouted out by a solitary genius or a geek, as the case may be, who's been toiling in isolation for years. Scientific discoveries are rarely so romantic and rarely spring from a single mind. My favorite example of this is oxygen. Very important scientific discovery, the beginning of chemistry, but oxygen was discovered, if you will, at least 6 times over a period of 500 years. Discovered, rediscovered, lost, rediscovered. So 6 times over 500 years, and cannot in any way be ascribed to a single person or in any particular date, although in many accounts and many textbooks, you'll find that it was Antoine Lavoisier on June 24, 1783, which is ludicrous, but often quoted. A second common mythology, I think, is the so-called arc of discovery, which traces a smooth curve of miraculous discoveries over centuries of near-perfect experiments. Physics would be a great example of this, proceeding from Copernicus to Kepler, Galileo, Newton, Faraday, Maxwell, Einstein, voila, physics. So appealing as these may be to the journalist or the historian or the science teacher in particular, they are really frauds as well. And they lead to a perspective of science that I think is eventually unsupportable, as we're beginning to see in our modern culture. It's one that sees uncertainty as weakness, revision as an admission of inadequacy rather than as a victory, which is what I think revision in science is, a victory. That considers ignorance as a problem rather than an opportunity, or a failure as a fault rather than an opening. So maybe one more slide, I think there is. I'm fond of quoting Ben Franklin on this. This is arguably America's first scientist and father, who tells us that really the history of human error is much more interesting in a way than that of success, because there are really a small number of ways to be successful, an endless variety of ways to be wrong, to fail, to be an error, and that the history of errors might be more interesting. So it seems to me the one job of the historian of science would be to correct these views of science, to uncover the trail of interesting failures, make sure that the history of science is a repository and a record of the process, because scientists won't take care of that. And it ought to be then the place where the fraud is exposed. Thank you.
Well, thank you. That's very inspiring. And we'll have questions and lots of discussion after the presentation.
Sarah, is there a clicker thing? I have like 50 slides. So I feel that, it's fine, but I can also walk over.
Yeah.
Can you hear me?
Yes.
Yeah, okay, great. Thank you for inviting me here. I always like to start off a presentation in an academic setting by thanking the organizers for not only beginning to take part in stimulating academic conversation, but also for giving me a chance to dress like my two dream childhood jobs, NBA basketball coach and strikingly handsome Hong Kong assassin. On to more serious matters now. Now, in talking to my panelists on email, it seems like we have a good mix of presentations. Oh,
I'm sorry, yeah. That's what's fun. Don't kill us.
yeah. Childhood. Okay. So we were talking by email, and it seems like we have a good mix of presentations, some on big picture issues like the paper we just heard, and then some on specific projects. So I'm going to do the latter and present an overview of a new website and database that myself and some colleagues have been working on for the past couple of years. It's called Toxic Docs, and I think it's a demonstration of how ongoing scientific developments right now can affect historical methods and questions. So I'll start with this photo. This is the infamous 1994 federal congressional hearing where 7 tobacco executives declared, quote, "I believe nicotine is not addictive." Now the factual claim beneath that statement we now know, and it turned out to be, and there's no lighter way of putting this, a complete lie. I'm having trouble. Sorry. Oh, I got it. I got it. Arrows. Okay. All All right. Now, the class action lawsuits after this hearing succeeded because of what was sitting in the tobacco industry's basements and storage closets. Confidential documents that had been stowed away for decades, but that federal courts ordered open as the cases moved forward. The trials uncovered documents like this that proved repeatedly that the industry had known about the addictive qualities of cigarettes, but suppressed that knowledge from the public for decades. That this 1963 Brown and Williamson document, one secret reads, "Nicotine is addictive. We are in the business of selling nicotine, an addictive drug effective in the release of stress mechanisms." Now, all this tobacco litigation has had a huge impact beyond just the world of smoking cessation. It's provided a legal framework for similar actions around many other poisons: lead paint, silica dust in mines, PCBs, benzene in gasoline, asbestos, and polyvinyl chloride. And as in tobacco, the lawsuits have unleashed a torrent of never-before-seen data. Millions of pages about the inner workings of the corporations that produce products that continue to pose a new world of environmental health risk today. Now, on one hand, as a researcher, I salivate when I hear about new lawsuits because I know how helpful massive amounts of documents, data, are to writing the story of these poisons, to understanding when and what firms knew about the health risks of their products, and to uncovering how they responded to regulatory pressures. But there are a lot of challenges to working with them too, and I'd like to focus on these three today. First is the problem of volume, otherwise known as, "Oh my God, this is so much material, what do I do with it?" Second problem is the problem of analysis, how to find what you want in a gargantuan haystack of documents. Number three, what this all means for environmental health policy and qualitative research in the history of public health. So let me start by way of example with the first, problem of volume. Now, about 1.5 years ago, our research group received 1 terabyte worth of documents that had come out of cases filed against Dow Chemical, Monsanto, DuPont, and many other chemical firms. But our excitement quickly subsided when we realized what it meant to actually process 250 million documents, or about 4 million pages. We'd at least received the documents in digital form, but they were just scanned images, a complete mess, and they were not machine readable. That is, to the computer, a document like that on the left side there was just another picture, another image, no different from one of 2-time NBA world champion Al Gasol on the right. So in order to work with these documents, we had to first use optical character recognition technology, or OCR technology, to get the computer to recognize letters as actual letters, numbers as actual numbers, just like Google does with Google Books. So initially we said, no sweat. We'll just feed these into some standard commercial software off the shelf that we have on our laptops, and we'll be done. But by our back-of-the-envelope calculations, this would have taken at least 6 months to finish, assuming no computer crashes, which of course promptly began on a machine like the one I just showed. Sad laptops are simply not equipped to handle this kind of volume. So we had to look for another solution, and we found one called the Open Science Grid. This is a national consortium of universities, including this one, that pool together their computing power nationally. And what the Open Science Grid allows us to do is harness the power of thousands of supercomputers across the country from an individual laptop, no matter how sad or feeble. So we fed these unprocessed pages into the grid, and using an open source utility developed at the University of Wisconsin called HT Condor, we distributed our 4 million pages across the grid accordingly. So we had some documents being processed here, we threw others to Baylor, tossed others to MIT, etc., and then they all returned back to the central node, but with OCR. All told, we used about 10,000 computers at the same time, and we can compare the total time for 4 million pages on a SAD laptop, 6 months, total time on the Open Science Grid with 10,000 servers, 1 day. Now for litigation, this is a game changer. Revolutions in parallel cloud computing and processor speed, the The computer on the desk right there, my phone, is more powerful than a lot of $20,000 servers just 15 years ago, have made this technology more accessible and no longer cost prohibitive. In the past, one common litigation strategy for companies being sued was to do a data dump, just sending millions of unprocessed digitized files and saying good luck. But that's simply not possible now. But even with machine-readable text, we have another problem, and that's the problem of analysis. How do we actually find useful things in so many pages? Now, most people are familiar with blunt full-text searches, what you do on Amazon or Google Books. But those alone are pretty limited if you don't really know what to type in the first place. So we're creating a set of tools to help make that search process a little more targeted and refined. I'm going to go over some of those techniques now, and as I do, you'll also get a sense of what these documents contain. So one big task is to just put things in discrete buckets by document type. If you sample the set of documents, say just read 1,000 of them manually, you can soon come up with document categories with very discernible features. So one example I'll use is board minutes. Here we have a set of secret board meeting minutes from 1972 where executives from all the major chemical companies got together and planned a secret internal study to see whether polyvinyl chloride production might be carcinogenic in rodents. Now, this is a key event because they later hid results from regulators that same year. And it's not hard to write a script that identifies distinguishing characteristics and words in board minutes. Almost all of them, for instance, have a list of attendees and common words like agenda or minutes. Scientific articles, published and unpublished, are another document type. Published ones are pretty easy to identify. They're usually broken up into columns with volume and edition numbers, etc. This is an article in a pesticides journal about PCBs. Unpublished studies are a lot trickier, but they also have some hallmark features. We're finding they often contain a cover page like this with the word paper or study or unpublished, along with a name and affiliation, and most importantly, actually a lot of blank space. Public relations campaigns are another common document type. Common thematic words are strategy, media, and message within the same document. So this here is from the Lead Industries Association, a trade group, and they're distributing a tip sheet to lead executives telling them how to handle public concerns about abandoned lead mines on natural lands. So it gives a key message to be propagated and pounded it away. Quote, vacationers should not be alarmed. Abandoned lead mines pose no health hazard. Lead is an essential element in everyday life. And a conclusion, the public lands are safe. Now, another feature we have is named entity recognition. Now, I'm very interested in figuring out who the major personalities and networks are, executives, scientists, activists, politicians, lobbyists, in debates around these toxic substances. And we can write a script to identify names and then isolate and list the documents where they appear. So typically, not always, but mostly, a name is 2 or 3 capitalized words in succession with at least one that doesn't appear in a dictionary file. And we can describe this format like that, run a script on any number of documents, and return a list of common names. We're doing that with one subset of documents from that huge collection I described earlier, and it's a database of depositions from academics who testified on both sides of these lawsuits. If you look closely at this deposition on the left, you'll recognize the name Richard Dahl, the eminent epidemiologist who conducted the first studies of cigarettes and lung cancer, but later in the 1980s was testifying for a string of chemical companies. This was done pretty much in secret until it came to light that he'd been making $1,500 a day doing this for 2 decades, most prominently for Monsanto. Richard Dahl and other scientists' unpublished late career work will be featured prominently on our site. Now anyway, named entity recognition lets us quickly identify people doing this, so this is just some sample output from such a search. We told it to find capitalized compound words filtered through a dictionary file and to keep the last word, and it lets us start compiling a list of principles. So So these are just some of the examples of how to attack this giant stack of documents. And at toxicdocs.org, you can soon find a very quick 30-second synopsis of the site, an email list sign up to be informed of our imminent launch, and a few other things like social media links and that sort of thing. Toxicdocs.org, contact@toxicdocs.org is the email. Now I want to end by briefly just discussing the broader implications. The first is public engagement. Now there's a lot of grassroots activism, most of it extremely admirable, around environmental toxins. If nothing else, I think this database is useful because it lets people most affected by pollutants know they're not crazy. They're not crazy for thinking that these hazards exist and that there have been some efforts to suppress that knowledge. Having an evidence base for that, too, is a guard against unempirical assertions that all too frequently pop up in activist circles. Rhetoric about genetically modified foods, chemical trails in the air, vaccines, etc. With this, you can actually make some grounded assertions about chemical safety and corporations with this material. I think this site also adds potential texture to the current literature on unsafe products, most of which is anchored in what I call a tobacco narrative. Now that's not surprising. Tobacco is where some of the most deceptive corporate behavior has occurred. And for other substances, it's the companies with the dirtiest and the worst conduct that have gone to trial the fastest. It's resulted in books carrying titles like Deceit and Denial, Virgins of Doubt, Doubt is Their Product, Golden Holocaust, Origins of the Cigarette Catastrophe. And these are portraits of regulatory agencies buckling against powerful corporate industry for which they are no match. And that narrative, I think, is going to continue to be the primary one going forward. But as we explore these documents further, as we continue to obtain more and more, I think we'll uncover some different additional narratives too. Not contradictory ones, but just different new ones. Outside of this initial set of substances, there is a long tradition of public-private cooperation in the regulatory sphere that doesn't always end sadly, even though it usually does. Examples of regulators who actually withstood attempts to corrupt the process. So I think we're actually going to inject another complementary layer alongside the narrative we've already begun to establish very well. Methodologically, cloud and parallel computing allows us to excavate a huge number of documents with speed and low cost unimaginable 15 years ago. Even if you're not like me and you don't get excited thinking about poison all day, these methods will be useful for anybody with a lot of text records that need very quick, rapid processing. Finally, this collection has a lot of implications for regulatory debates over toxic substances. Most agree that the Toxic Substances Control Act of 1976 is woefully out of date, and this is actually on the floor right now. And I won't go into the minutiae here, except to say that of the two updated proposals that were debated hotly the past few years, the crux of the disagreement is whether the EPA, 1, should assume low risk until proven otherwise, or 2, assume higher risk and shift burdens of proof to manufacturers and firms themselves. I think there's enough evidence in these documents to consider the second and to suggest that the word of private companies alone should not be readily trusted before substances are allowed to circulate in the population. So my time is up, and I'm happy to talk more about the technical stuff and other things later. Thank you.
Thank you so much, Ross. Incredibly accessible.
So maybe I'll take the microphone. And I'm going to be talking today about Bartram's garden. I'll start off with just a short background because some of you may know nothing about the Bartrams, and then talk about some specific current research that's been published, scientific research, using data from the historic Bartram family. And I'll just give a little background that my graduate program was at the University of American Civilization in the 1980s. And at that time, that was kind of an anti-history department. It was formed by professors that had left history or other departments of the University of Pennsylvania and banded together into a program. So in many ways, what I've been hearing today in this conference about history PhDs didn't really apply to what we did. And my background was archaeology, so I was training as an archaeologist, and there always are jobs for archaeologists, but I guess I got bored with archaeology in that what you find doesn't always tell you what you really are interested in, and so I became interested in historic gardens And you find certain evidence from archaeology about historic gardens, but you don't really find a whole lot about plants. So that led me to look more and more into the primary documents about the Bartrams. So just as background, there's more than one Bartram. It's actually 3 generations of a family. This opening slide on the right, you have John Bartram's house, Quaker botanist, born in 1699. On the left, you have a piece of mechanic art by one of his sons, William Bartram. So again, in thinking about this talk, I don't often think of my site or my specialty as just science. I, in fact, don't even think of what it is often. Maybe I should more, but the Bartrams overlap a whole range of things. They're involved in art, they're involved in horticulture, and multiple kinds of modern science, which they all subsumed under what they just called natural philosophy. So we don't know what John Bartram looks like. This is a stand-in picture we use. It's actually an 1879 Howard Pyle illustration from Harper's Magazine. John Bartram is known today mostly because a large collection of his correspondence survived, and it was actually published in 1849 for the first time. And many of those letters are to a important London intermediary, Peter Collinson, who's very important in Benjamin Franklin as well. And you may not know that Benjamin Franklin's scientific publications on electricity were originally personal letters written to Peter Collinson. The most famous son is William Bartram, who at age 11 began traveling and collecting with his father, eventually went on a very long trip to the American South on his own, published a book that is still extremely popular and widely read, William Bartram's Travels, first published in 1791. So Bartram's Gardens, here on this map, it's the somewhat classic green rectangle and triangle right along the Schuylkill River. Actually, I was pointing out where it is in this area here. It's about 46 acres, surrounded by either derelict industry or still current industry on a river that by 1900 was totally dead with nothing living in it. The river has now come back and is very alive, full of fish and wildlife. So we're kind of on the interplay between industry and nature. So in the 18th century, the Bartrams, and particularly John Bartram, didn't ever use the term science, but he thought of himself as a philosopher, a natural philosopher. His philosophy or science can now be divided into dozens of specialties and subspecialties. And to some extent, there are people in the modern scientific world interested in what the Bartrams did in the 18th century. So John Bartram's science can be considered biology, can be considered botany, zoology. But under zoology, you have mammalogy, ornithology, herpetology, et cetera, et cetera, et cetera. Earth sciences, geology, meteorology. I should have put environmental sciences, even ecology. The Bartrams are kind of proto-ecologists. Anthropology and archaeology, they recorded native ethnographic material. They actually excavated native burial sites. Chemistry, astronomy, medicine. So all these things have a play in the surviving corpus of documents from Bartram's garden. John Bartram, with Benjamin Franklin, founded the first American Scientific Society in 1743, the American Philosophical Society, and on the, I'm sure you know what Benjamin Franklin looks like, on the right is William Bartram's certificate of membership in the APS. So 18th century science doesn't really always look like what we think of as science. It doesn't look like geeky science. It doesn't always look mathematical. John Bartram's science often is just lists of plant names. So this is one example. It's on the left, a numbered list of, I think, 105 or 104 specimens being sent to England, actually for sale. So one of the reasons John Bartram could be a scientist is there was some commercial value in what he was collecting. And on the right is a page from the Gentleman's Magazine, I think that's 1754. Again, it's a numbered list. In lots of the historical accounts of John Bartram in the early 20th century, they would reproduce one of these lists as if that was an example of everything he did. But in my research, I found there are dozens, probably maybe as many as 30 or 40 of these lists. And one of the reasons I'm here speaking today is that over the years, I've been involved with Pamela Smith's Making and Knowing project, and a couple of years ago, I published an article compiling a series of 5 John Bartram lists into tables like this, and then applying modern scientific names. Because one of the problems is the names that John Bartram uses are not our modern binomials, but it's not impossible to identify what he's talking about because we know where he went, what he collected. In some cases, specimens survive. So in some cases, this is sort of a translation exercise. It's translating from one set of terms and language into what modern scientists use. And interesting, modern scientists often avoided doing this. In fact, there are books saying, well, we're not going to even attempt to identify John Bartram plants because we might make a mistake, but that throws away a whole level of science. there's some very good modern scientific databases that can be used for identifying these plants. So these are just two examples. Tropicos is from the Missouri Botanic Garden, and USDA's plants.gov database, where you can type in old names and new names and find information. And Tropicos in particular, if you look on the far right, is organized by date. So it'll give you every name organized chronologically. So there's something very historic involved in modern scientific plant and biological nomenclature. So some examples of Bartram data. So in the British Museum, Natural History Museum, there are large bound volumes of urban specimens. 3 big volumes sent to Sir Hans Sloane, close to 300 specimens. Only very recently these been available for researchers because you had to be a botanist, you had to make an appointment, and go look at that volume. These are now all being digitized, they're online. So you look at the picture on the right, there is a little square of paper down there. That's John Bartram's collection notes, where he says, you know, I found this in this location. This plant is used, and there's often ethnographic material about how they're used, where he collected them, exact dates, and again, his names. So John Bartram is working in a world where Linnaeus has just appeared, and so a lot of my research also has to look into the whole concept of Linnaean botany. This is an example of Systematura, the first Linnaean publication on the left, the actual sexual system where he's organizing the plant word on the right. We know John Bartram had access to a copy of Systematura 1 year after it was published in Europe, in Philadelphia, and was using it and following Linnaeus' system. He corresponds with Linnaeus. John Bartram eventually owned maybe as many as 10 to 12 Linnaean books, all the catalogs and books as they came out. So here's an example we happen to own in our special collections library, signed by John Bartram and then his son William Bartram. What's interesting is modern taxonomic botanists take a very limited view of their history, but they really still view what's probably an improper scientific history, that there were these great men. So Linnaeus was the great man. He applied these names, so we must conserve his names, or we must find the first person to ever publish a name. But their fight to find the first person to publish a name becomes very, didactic. It becomes useless to some extent. I mean, they're trying to find out when was this particular print and fascicle of text printed. Was it printed in October of 1791 or September? And if so, does this then precede someone else's discovery? When, as we know, as we just heard, science is a group cooperative effort where many people are working. So this obsession, and really kind of weird obsession, research into who was the absolute first to ever publish a name kind of detracts from the history of science, and particularly from the Bartrams. Well, certain other kinds of data we have available. We have medical data. The son William Bartram compiled a pharmacopoeia, which is very high-level European science. He made illustrations for medical dissertations coming out of the medical school of the University of Pennsylvania between 1796 and 1805. He collected meteorological data. So there's a whole set of sheet tables from 1790 to 1791 at the APS in Philadelphia where he recorded temperature twice a day, barometric pressure, wind directions, a little bit on climate. This is incredibly valuable climate data, and something that we're very interested in right now is climate change. So having this data from the 18th century can be helpful as a baseline, although whether it's been researched or not, I don't know. So some of this data I'm just going to show you that exists. William Bartram also kept a garden book the last 20 years of his life. Similarly, every day he would record what the weather was like and what was in bloom. So he's often reporting what was first to be in bloom and what birds are arriving. So again, this data can be used to reconstruct climate and when spring happened in any one particular year. So in effect, there's a famous year without a summer where there were frosts in New England that killed off all the grain crops. Well, William Bartram records that year in this book. So finally, some various kinds of science and scientific research that's been happening at Bartram since the last 25 years. Of course, archaeology, I could talk to you for hours on archaeology. This is just one example where we restored a tidal wetland along the Lower Schuylkill and planted it with environmental plants that once were native to the Lower Schuylkill. Before that, we did archaeology. We found a prehistoric site. So in 2 different phases, in '96 and in 2012, we did some significant archaeology and found you can see distributions. That map down below shows ranges of distributions of prehistoric artifacts, and here are just some examples. Those stem points are what are called the Archaic period, roughly 4,000 to 1,000 years before present. We also found material that was before the Bartram. So our site was part of the New Sweden colony. There were Swedes and Danes and Germans living in the area before the English Quakers came to Philadelphia. So there's a William and Mary period halfpence there, and a piece of English graffito earthenware that dates from the 1690s, before John Bartram was even born. So a few cases where people have published on the Bartrams. The Bartrams discovered a very important plant called Franklinia that is now extinct in the wild. It survives in cultivation because the Bartrams found it. And on the right there is William Bartram's drawing of Franklinia. Well, in recent years, there's been quite a bit of research because Franklinia is in the Teaceae, the tea family, which are very important economic plants, of course, you know, for tea, for the flowering plant camellia. So here's an example of a scientific paper where they're hybridizing Franklinia with several other species, particularly Skimmo, which is an East Asian species, producing a hybrid, hopefully sterile, which will not contaminate the small number of Franklinias that still survive. In 2008, a scent chemist, Roman Kaiser, from a Swiss chemical firm Givaudan, came to Bartram's Gardens to capture the scent of Franklinia. He's publishing a book on the scents of endangered species, so he put these little globes and did his little technological mumbo-jumbo to get the scent molecules from Franklinia. A couple herbalists who live in West Virginia have been cultivating and experimenting with Franklinia because of its similarity to tea. Hassan Amjad and his assistant there, they sent Franklinia material off to be analyzed and found that it has very much, the leaves of Franklinia have very much the same chemical compounds that are found in green tea, and you could make a very helpful beverage with all the alleged properties that green tea has that are helpful. These chemicals called catechins and epicatechins and caffeine. There's about a quarter of the caffeine in Franklinia that we find in tea. So another example of an extinct species, in this case it's a bird. In the past 5 years or so, I've been doing research with an ornithologist, very eminent American ornithologist, Noel Snyder, who's interested in this bird, the painted vulture. William Bartram describes this bird, we now know, twice, both in the 1760s and then in the 1770s in Florida. It hasn't been seen in Florida since 1800, and it's pretty, it certainly is extinct. It's a bird very much like a known bird, the king vulture, which appears in the Caribbean, but its characteristic is it has a white tail with a thin band. So it's even described once in the 1760s as the white-tailed buzzard. Noel Snyder discovered there was a 1734 illustration of this bird being held captive in London and being displayed at a tavern. And so that, with very specific documentary messages in the Bartram letters, allowed us to write a paper arguing that this bird really did exist and that people should start looking for any material evidence of it. And so we published that in Zootaxa. And I'll just point out, when you publish something, when you're a historian, you publish something in Zootaxa, the spam you get suddenly changes dramatically. I now get spam about genetic engineering and DNA collagens and all kinds of other things. So finally, another researcher has been looking at the spread of Ailanthus, a very common tea tree. Almost all probably know Ailanthus. The tree that grows in Brooklyn is the Ailanthus. Well, it turns out that perhaps the first reproducing population of Ailanthus was at Bartram's Garden. So a researcher from Penn State did a PhD on many aspects of Ailanthus, but particularly its original spread. We found that there's a tree, it's in that photo on the far right, that we think was given as a wedding gift to the third generation of the Bartrams in 1806. That was a male tree. Shortly after there, a female tree was acquired by the Bartrams. And this is a map from the 1930s. The red marks are Ailanthuses that were living, including the historic one, which was this one, which was the wedding gift tree. But then by the 2010, we had trees in different places. But some of them seem to perhaps be suckers off the roots of that original tree. So anyway, Matt Casson was able to do tree coring and DNA analysis of these trees. So just a bit of a summary here. There's a lot of potential scientific data in old scientific work that is not always considered by modern scientists. So thank you.
And I'm also a Brooklynite, so the fact that the Ailanthus comes from your garden.
Yeah, you can blame us.
Yeah, really. Anyway, going in and out of the micro and macro, I'm presenting a more macro do with trade books publishing of historic narratives of science. I'm the publisher of Bellevue Literary Press, which is a small, nonprofit, mission-driven trade book press devoted to publishing nonfiction, narrative nonfiction, and literary fiction at the nexus of the sciences and the arts. We're a project of the NYU School of Medicine, though we're wholly self-sustaining, which means that we spend a significant amount of time fundraising, since trade book sales are not what they might be. You may have heard about this. Fewer people read long-form narratives, we've been told, although it's always been tough to sell serious, substantive books. But our impact can extend well beyond the numbers. It's not just how many books you sell, but who reads those books that counts. The book remains a democratic form, however, as long as libraries exist, and those are in peril as well, so we have battles on all fronts at the moment. But we do what we do because we're passionate about it, and we believe in the power of narrative. Against all odds, our small press made it onto the cultural map, and we won a Pulitzer Prize in Fiction in 2010 for a debut novel called Tinkers by Paul Harding, which was followed shortly thereafter by a National Book Award nomination for another first novel called The Sojourn by Andrew Kribach. And this recognition has kept us alive when, as I mentioned, the book itself as a form is imperiled. We've sold over 500,000 copies of Tinkers since the Pulitzer, as opposed to our average print runs of about 1,500 copies. That's a first printing. If we're lucky, the book's backlist and we reprint. And the narrative nonfiction tends to backlist more readily than the fiction, by the way. We publish 8 books, divided half-half, fiction, nonfiction, per annum. So I tell you this for a little bit of context. I don't know how much you know about the publishing business. Since we operate in the commercial side of the publishing business, quote-unquote commercial, because our books sell through mainstream bookstores and Amazon primarily now, that's how the business has gone. The sales aren't that different from the sales of academic books. And the dirty little secret is they're not necessarily all that different from comparable analogous titles that are sold by mainstream commercial houses as well, who make their successes by selling genre fiction and celebrity biographies for the most part. Not all of those succeed either. It's a crapshoot. It's a very tough business, even for the big guys who are our competition. But then the question might be, what does all this have to do with the interplay of history and science? I brought some examples of our books. These are straight-on science history books. Biography of Heisenberg, a book called Starlight Detectives, How Astronomers, Inventors, and Eccentrics Discover the Modern Universe. This is a book written in stone about the history of the fossil record and the evolution and the development of evolutionary theory, and how, as the theory develops, our understanding of the record changes. This is an intellectual history by Jonathan Moreno of science since the founding of America. This is an interesting story, public health story. I don't know if anybody remembers Reye's syndrome or Ray's syndrome, pronounced both ways, but I'm old enough to have remembered when aspirin went out for kids and Tylenol came in, and that was the result of Reye's syndrome. We'll look at the details. So this is just a part of our list, but these are the books that I brought in because of the subject focus of this discussion. Our authors tend to be academics who are interested in reaching a broader audience. The books that you featured on your PowerPoint about the merchants of doubt, et cetera, are examples of analogous types of titles. So we can't pay them large advances, so we tend to, the books that don't sell to the mainstream houses for large advances might come to us, and they just might be a little bit more substantive. We're interested in the big questions of science, and such as how does creativity figure into the making of science, questions of ethics and moral responsibility, civic duty in the scientific endeavors, all of which can be examined in depth via historical narratives, which can effectively describe how science is done and why. History is story, after all. It's creating narrative, and it's also creating plot and consistency where none may exist. I think it feeds very well back into what your subject was, Stuart. And there are two sides to that. The struggle for us is to make sure that science is accurately represented and made accessible to lay people who don't have an academic background necessarily, or may have one in a different field, without distorting the science itself. And you may argue, and as an English major who grew up and was educated in the post-structuralist period, where we're all, and I'm sure history is doing this too, and has been for a long time, we're all interested in meta-narrative and what narrative communicates and how it makes meaning and how it can mislead. So there's a constant struggle for authors of serious science, writers of science, whether they're academics or science journalists, and publishers who feel that this is their mission to communicate science to a broad public in a accurate way. Not to distort, but to make accessible. And when you're very conscious of the vagaries of the marketplace and how difficult it is to capture that, the attention of the overcharged 24-hour media cycle. Part of our job is to reduce things into sound bites that will be picked up, because if the message is too complex, it will be ignored. So it's a tightrope act. How do you manage that? How do you make something exciting to people without misrepresenting it? And so that's our challenge, and sometimes we do better than others at that. We can think of books called, for instance, the title of The Selfish Gene, or The Gay Gene, or The Math Gene. I mean, obviously there's no such thing, but the notion of a math gene, a book written by Keith Devlin, who's a serious mathematician, he's not writing nonsense. His publisher undoubtedly was thrilled by that title, because the notion that there's a math gene is exciting to the media, and allows this book to get play that it wouldn't necessarily otherwise get. So I'm very interested in how what we do feeds into what we've all been discussing, and I hope we have time for a conversation.
Thank you very much. What time do we actually need to close this?
Technically 12:15, but lunch does not start till 12:30, so we can.
Okay. So just to tie these really interesting remarks together a little bit, the main theme that I took away from this was that science needs history. So Stuart is telling us that history can reveal the nature of the scientific process in a way that dispels the myths that we've that scientific papers propagate Merlin tells us that history can open science up to public scrutiny and give the public access to hidden side of science. Joel shows us that history can actually uncover new evidence for the sciences to work with. And Erika shows us how history can communicate science more effectively, no offense, than some scientists might be able to. We have the exceptions, certainly. So I want to open this up to your questions because we have some wonderful experts here as a resource for all of you. We also have a lot of experts in the room on the relationship between history and science. So I encourage everyone to take part in that.
I think when we talk about public history of science, we tend to split people into a few very broad groups. Historians, scientists, and non-historian non-scientists, which I'm wondering if you have a more specific vision of what the public means for you. Is it a sort of just a wide readership in any capacity, or do you have a vision of your target reader? So who is the public for whom we're doing the public history of science?
Is that directed at somebody in particular, or
I'm sorry?
was that directed at one of us?
No, just anyone.
Okay. Well, I guess I would just say I would prefer not to be exclusionary. I don't see any purpose in excluding anybody, so the wider the readership, the better. Target. It's always, we tend to use this word, the lay public, which I always find kind of odd, that because of the religious connotation of the word lay in this regard. But I guess you mean the sort of non-expert or non-trained public. I always have this question as to whether, am I really any more equipped to understand quantum physics than any other non-physicist, just because I'm a biologist or I have some scientific training? And I don't really know the answer to that. I think there is a little bit of, I think I have a little bit of an edge, but the edge is a kind of an intuitive one. It has nothing to do with my training as a scientist beyond this sort of ineffable kind of, what do they call it, tacit knowledge, I guess, that Michael Polanyi first thought about, have developed, that you learn some sense of who to trust or who not to trust about facts. And this is quite critical in the public policy area. I would say, for example, when we talk about this, it was very obvious, or it's become obvious retrospectively in the tobacco situation, in maybe in climate change, it's becoming so. But I think it's still up for grabs in genetically modified organisms for crops. There's a large number of people who I think unscientifically have adopted a very anti-GMO position, based to some extent simply on their mistrust of large corporations, which is not misplaced, mind you, probably, but nonetheless is not scientifically based, and I personally think it's quite problematic. So yes, disseminating that kind of information. It's a big joke all the time, and the 48% of Americans don't believe in evolution or something, whether we want to teach intelligent design in our school curriculum. But a recent, paper by one named Susan Jasnoff, who's a sociologist, asked a question of European high school seniors. I think it was seniors. The question was, the statement was, genes are only found in genetically modified crops, true or false? And 28% labeled that statement as true. That's a disaster to me. That's worse than 12,000 kids in Kansas getting a crappy biology education because they don't learn evolution. That's not good, but it's not really in the end. But people who take this attitude towards genetically modified crops, as a consequence, there are millions of people starved to death. Now, you can go back and forth on the issue, but I don't think we have a good scientific angle on it. So I don't know if that's a public policy issue there. How you disseminate that, I don't know. Vaccines is another example.
I think, again, it's the problem of narrative, and the idea that narrative, there's no such thing as a neutral narrative.
Mm-hmm.
You're trying to communicate either an exciting story or a story that will get somebody to vote in a particular way or promote a product or make sense of your chaotic life. You know, this is any form of narrative, whether it's autobiography or history of science. So when we tell stories, we create meaning, and we create specific meaning depending on what kind of subjectivity we are. So you can't remove that.
So I
equation.
tend to agree with you, and I think it's it's one of the things that's missing to me in science education is that we just spill facts on people and become some kind of a memorization marathon with no real story. And I think the stories are really important to actually understanding it. On the other hand, the stories do have the nature of story or narrative has a tendency to, as you put it, sort of not simplify, organize. And I think one of the key aspects of science actually is how disorganized it really is. And that's often not been very well presented in narratives of science. It's difficult, and I think that's a real problem for historians.
To this point?
Yes, but really for all of you too. So given that, I mean, one of the things that has always struck me in dealing and working at the intersection of history and science and public policy is the degree to which the scientific community and public policy community likes to push back against critique of, it doesn't like those, I mean, you know, the history of failure would be a great book, but the degree to which, say, for instance, the Centers for Disease Control and Prevention really hates to have its moments of failure exposed, and the ways in which the scientific community will put pressure, just like you have sort of industries creating pressure to put pressure on congressmen to push their narrative, the ways in which the scientific community itself will create pressure on those who would dissent and disagree is a really important story to keep in mind, because that's been my long experience of looking at this intersection. Stuart, I'm particularly curious to hear sort of what your experience and knowledge of the ways in which the field tries to quiet dissenters.
Not only among the public, but within the field.
Yes,
I mean, you go to funding agencies, and there are, they're very, what's the right word? They're not rational often decisions about funding. They're quite irrational sometimes because somebody's trying to push something that's, one of the very quickly, one of the great stories of this was the story of the bacterial basis of ulcers. So for years, it was a huge industry, which considered ulcers to be a nervous condition, like baby behavior, if you remember all that nonsense. And there was a huge pharmaceutical industry and gastrointestinal industry built around this notion of ulcers. And then it turned out, although the idea had been around since the early 1950s, that ulcers were actually caused by bacteria. And Robin, what's his name? I don't remember suddenly, but one Nobel Prize for this showed that ulcers are in fact caused by bacteria and be treated by antibiotics. Humans don't really sell. So there's no money to be made in antibiotics. So the pharmaceutical industry didn't want to hear that. And if you look at the record of NIH funded proposals, you'll see that there are many people trying to pursue this bacterial basis of ulcers, and their funding was just turned down in distortion, out of hand. It wasn't the fad. It wasn't what was going on. I agree. But it's critical to write this history of failures. It's very hard to do. I actually tried that a little bit in a recent book. And, as they say, history belongs to the winners. And, the failures don't often get recorded way back when. So that's why we come up with these arcs of discovery narratives. But we need to do the research, the scholarship to get around that.
So can I just jump in to ask a question? There seems to be a bit of a contradiction in the messages that Erika and Stuart presented. One is we need histories of science as disorganized and complex and full of disagreement, and the other is we need narratives that are relatively simple to sell. So how do we come to terms with both of those?
I think it's a tension. It's an ongoing tension, and I don't see it as a contradiction. I see it as, again, a tightrope walk that has to be negotiated with great care. And it comes down to issues of responsibility and ethics, really. And critique, constant meta-critique, which I hope that and assume that historians are practicing all the time, I would hope.
I would just add, it depends on the audience. At our site, people come for all kinds of reasons. We you get college students that are there for a class, they're there for landscape architecture, they're there for history, they're there for science, they come from all the universities in Philadelphia. So we approach them in a certain way, but then we get high school kids, we get kindergartners, and then we get just casual visitors who don't want to be bothered. And they might want to know, well, what is this place? They want something very short, like one paragraph to tell them, and then they can wander off on their own. So one problem I've always found with a lot of historic sites is they try to craft one perfect narrative that then gets repeated by other people over, like the Park Service, National Park Service sites are famous for this, that their historians craft the perfect narrative for, the Statue of Liberty or Independence Hall, and then underlying people, rangers, repeat that story, but it doesn't ring true to the people hearing it because it's the same every time and every consistent meaning. So I don't know, I think you have to take the audience, and probably the same for books. When you're selling a book, you have to think of who you're writing the book for.
Absolutely.
I'm thinking of Spencer Weird's website on the discovery of global warming, which kind of tells one very simple narrative if you just read the major headings, but then if you click, there's a hypertext, you get into more of the complexity. So maybe that's a model. I think it's a model that a lot of us use in our teaching also, kind of teaching at one level, and then there are modifications and complexifications that you can give at lower levels, right?
But you never escape creating an organization and a hierarchy of information creates a specific narrative. You cannot escape that. That's sort of the human.
You don't get your message across if you leave that out.
It all comes down to communication, which is an impossible task. Whether you're talking to 1,000 people or one person, right? So.
I had kind of a related question. I had a chance to take a graduate course in evolutionary biology at Columbia recently, and a large part of the course was kind of debunking, what Darwin originally said in The Origin of Species and the connection between the political ideology of social Darwinism and how this, is a very complicated idea that arose in a very different context. And so I was wondering, you said earlier that science needs history in a sense to make it relatable to a wider audience to construct a narrative, but it also seems that, the history also really needs the science in order for it to be well understood and those narratives perhaps corrected. So a related question is, how are you going to go about, as kind of practitioners or academics in your field, kind of correcting these narratives in everyday life? Does that come from training historians to also be scientists, training scientists to also be historians? How do you think that's going to be addressed?
Great question.
I'll just talk. I think one issue with graduate training in history is that it's very balkanized. So I just went through a regular history program and got a PhD out of a history department as a historian of public health. And then at the same time, I was getting a master's in public health, and the faculty from both of my respective programs never talked to each other once. That's a problem because they both kind of work on things where they could benefit from one another, but the campus bureaucracy and institutional incentives aren't aligned so that that kind of thing can work. I haven't been on campus enough here to know how it works, but I know in some places people have to fill out 6 forms to register for a course in another department and stuff like that. So if you're not getting historians speaking to scientists and vice versa, kind of insights that I think you would like to see aren't going to happen as much.
I must say the sciences must be just as equally balkanized as the humanities in this regard. And certainly true in biology, which has within sub-departments as far as I'm concerned, let alone the differences between chemistry and physics, and always a tremendous difficulty, no matter what the university policy is on promoting interdisciplinary this, that, and the other thing. That's all usually a load of crap, frankly, because when you go to do it, it's quite difficult, as you said, and the administrative incentives aren't there. In fact, there are a lot of disincentives. So it seems to me the only way to make that sort of thing work, and there's enough people who want it to work, is to find sort of outside the normal institutional parameters, mechanisms for doing that, which could be anything from meetings like this to bars, and just having drinks together. So, but all of those things I think are probably what will finally make a difference in that area. Not changing the silos around or opening them up, which I just think will never happen.
Well, would the fostering of a more robust generation of public intellectuals lead to this? Because I think that when you try to move out into a mode of communication that addresses the broader public, you necessarily become interdisciplinary. Because you're leading the academy to confront the so-called real world. So it's, I think, as a trade book publisher, that's really very much intrinsic to our mission, is creating a broader discussion that's essentially interdisciplinary.
I think that, I have to say that's very true. I don't mean to hijack the conversation, but so I wrote these 2 books, and I never planned on writing a book at all. I'm a scientist, I write papers. And then an opportunity came to write this book, so I thought, well, I'll give it a try, and then it did okay, so I got a chance to write a second one. I actually love writing books, and it turned out I had no idea it would be fun. But one of the things that really impressed me about writing books, in spite of that sort of doom and gloom, and appropriately doom and gloom attitude towards books, is that you write a book and you get emails and calls and invitations from all sorts of people you would never have had access to or even known existed before in all kinds of different fields. And so it turns out writing a book is a very, very potent thing to do and does connect you up in many ways with people who you normally would not have been. At least that's my experience.
May I coach you?
Yes, absolutely. I'm really quite surprised by it, yeah.
But no, we find that too. So there have been in the last decade several dozen books written on the Bartram. So for some reason, the topic is interesting. And so we often have book signing events, and we get a very different crowd. You always get a very reliable crowd of people that come to literary events. We also have art events. We're up to get anyone to come to our site, but books have a very, in spite of the gloom and doom, there seems to be a survival. One thing I'll say though is I've participated in writing lots of books in the last 20 years, but I must never get paid anything for it. I do it as part of my job, so I do get paid, but it's not like there is any money in doing, that kind of book.
That's why we're a nonprofit.
Yeah.
Unfortunately, we need
Both
to
legally and literally.
we need to wrap up the conversation. I just want to draw out something essential, I think, in what you said, which is that it's not just historians of science, but historians in general who need to understand the science, because so much of modern history in particular is kind of history of science undercover, right? Things like social Darwinism, which appear in every modern history textbook, often very misleadingly, right, associating them with Darwin theories. So one lesson might be that we need to collaborate more on textbooks, right, across the disciplines to, get down historical narratives to get it all right. I just want to say thank you very much to our presenters. Very fascinating material. I also want to let you know that I'm going to be directing the History in Action program next year. And so I encourage you strongly, come talk to me about your own ideas for next year, your own visions. I'm really eager to start brainstorming.